All right, for my first example of an indefinite integral that we're going to do, I have chosen to do the indefinite integral of cosine of theta divided by sine squared of theta d theta. Now notice we're not using x's in this case, we're using theta as my variable, so that's why it's d theta and not dx. Now, so here I go. I'm going to look at calculating the antiderivative of this function. Now, there's a couple of ways to do this. The way I'm going to suggest to you guys to do this is to actually split this up into two separate fractions. And so I'll write it like this. I'm going to take the cosine and put it over just one of the sines. And I'm going to do the other one as 1 over sine. So notice all I did was split it up just a little bit to try to make my life easier. Now notice it still is the same function. It's still 1 times cosine, which is cosine, and sine times sine, which is sine squared. But now I can kind of use my trigonometric identities and simplify this a little bit easier. So 1 over sine is actually cosecant, and cosine over sine is cotangent. Now, if you remember back to when we were doing the integration rules, the integration properties, those different kinds of integrations that we were doing with definite integrals, we actually saw what this kind of formula was. It was cosecant, but it's a negative cosecant. So the antiderivative of this function right here, cosecant theta times cotangent theta, is actually negative cosecant theta. Now, again, the difference here is I'm no longer evaluating over any bounds. I don't have a number on the bottom or a number on the top. So what I'm going to do is make sure I add in the constant of integration. Okay? Now remember, that c could be literally any number. It could be any number that we can think of. It could be 0, could be 1, could be 2, could be -5, could be literally anything. So right now, this is going to be my answer, the negative cosecant of theta plus c. C is that constant of integration. Make sure you include that every single time.